Okay, friends, welcome back to Cycle Space Engineering Services Training and Project Division. Today we want to go into the second part of the simulations, the silo simulator. Silo simulations. We're going to simulate how this system will use this control panel to control the PLC so that this box will come in here, get filled, and then move out. Okay, the question says, the sequence can be stopped and restarted at any time using the panel mounted stop and start switches. The run light will remain energized as long as the system is operating automatically. Please note this, because that is going to be the point at which we are going to manipulate the entire system. If not, it will become difficult. Okay, the fill light will be energized while the box is filling. The full light will energize when the box is full and will remain that way until the box has moved clear of the probe sensor. This is another pointer. If you miss this last point, you will never get this program. This last point is to help you to be able to make sure that the box actually moves away. If you miss this last point, your box will not move away. Your box will move a little bit and then your belt will stop and the filling will start and then pour all over the floor. Okay, so let's start. So the first thing, this run light that's supposed to be on at all times, we are going to use it as a control to control the program. So what I do is we go to our panel. So we'll add a new run. So here I'm going to have a stop. That is the stop, the general stop. Okay, stop. Okay, that is the stop. Then I'm going to have the start. Okay, here is the start. Here is the start. I'll call this stop. This is stop. I'll call this stop. Then my concern here is to energize this run lamp. Energize the run lamp. Okay, this is the run lamp is 202. Okay, then I will need to keep it running. Okay, so I am lashing the run lamp. Keep it on. Okay, so this is the first thing we need. Now this run lamp will remain on. It has no problem with anybody until I use my hand to press stop. Okay, so the next thing we do is to look at the belt. So we are going to use the NO of the run lamp to energize the belt. As long as the run light is on, the belt will be on. Okay, so this will be the belt, the conveyor, and this is the conveyor. Okay, so this is the conveyor. So as long as the belt is on, and the conveyor will always be on. So as long as the non-indicator is on, the conveyor will always be on. Okay, so the next thing is we need to stop the box. We need to stop the box because we want to fill it. Okay, who stops the box? Okay, we stop the box, and also we also need to restart the box. Okay, I will come. Let's actually look at this. Let's run this one. Let's see if we're in the right track. Click start. You can see. Okay, it's okay. Let me increase the scan time so that the speed will increase a little bit. Okay, so that is it. You can see. So we are in the right track. So gradually we are going to this. The first phase. Okay, done. So we are going to finish the other one now. This is let's perform the simulation. Okay, let's look at the conditions the conditions to stop the belt. Number one, when the box come under the sensor. Good. So we are going to when the box come under the sensor, that is probe sensor 3, when it comes there. Okay, now another one is one other condition is to stop the belt. When the filling light is on, when this filling light is on, the belt should not be moving. Okay, good. So when the filling light is on, the belt should not move. That is filling light. When it's on, that means that is a filling is going on. The belt should not move. Then when it finish, when do we restart the belt? When the full, when the box is full. So we're going to use the full to do the restarting. Okay, it's very important. We use the full to do the restarting. Okay, good. And the full is, this is the address. Okay, so the next thing is to create the rungs for the full lamp and the fill lamp. Okay, so the next thing is we look at the filling lamp and the solenoid valve. That's the next thing we do. Okay, so on that, number one, the motor mustn't be running. The conveyor mustn't be running. That's number one. Number two, the sensor, the proximity sensor must be energized. Okay, it must be energized. This proximity sensor must be energized. Okay, it must be energized. Okay, and the level sensor must not be energized. Okay, that means we are using the NC of the level sensor. It must not be energized. Okay, it mustn't be energized. That is, we're using the NC. Okay, now at this point, the full lamp, we'll have the full lamp. The full lamp, we're going to use the NC. Okay, the full lamp, because at that point it's not full. Okay, these are the conditions to help us run our. So at this point, when these conditions are met, okay, our solenoid valve comes on. But our solenoid valve, while it is filling, we want the filling indicator to come on. So what do? We pick up a branch here, put this branch, put this the coil inside, then take another coil right inside, and we will call it what? The fill. That is the filling process. So when this filling is going on, okay, this man is open, conveyor cannot move. But once it is full, okay, this man will create a bypass to actually continue the belt. So the next thing is we need to create the full, okay, the full rung, the rung for the full. Okay, it's easy. What we'll do, new rung. Okay, number one, we need the full rung. This man, once this man activates, that is our full. So it's easy. That is our full. Okay, good. Then we need to make sure that this full lamp actually is maintained for some time, so that it will cross the sensor without having problem. Okay, so we put the output coil, then we put the full. This is the full. Yes, correct. This is the full coil, full lamp, the full lamp coil. Okay, then we lash it. Okay, but at this point in time, we also need to stop it. It should be stopped once it passes the sensor. Let it stop. Let the full lamp go off. To achieve that, we take this sensor, we put the NO of this sensor right here. Now this two will energize immediately. It passes this sensor. This sensor energizes, and this man will energize. Then this full lamp will go off. You see the trick? Okay, good. So let's look at the program and test it. What we're seeing here, it will be filling is automatic. This is automatic. It will fill. After filling, the belt will continue. It will fill, restart the belt, and then to continue. It's automatic. It comes under the silo. It gets filled up. It gets removed. Another box comes in, gets filled up, gets removed. It continues like that. That is what we call continuous production. So let's see if the program is right. We'll download the program and we run the program. Now click start. Okay, let's see how it goes. Beautiful. That is beautiful. It's good. Beautiful. It's excellent. Okay. Excellent. So the next thing we do, we go into the exercise 2. Okay. This one is done. If you watch, the run light will remain energized as long as the system is operating automatically. That was achieved. The run light, conveyor, and solenoid will de-energize when the system is halted via the stop button. We'll test that now. The fill light will be energized while the box is filling. We got that. The full light will energize when the box is full and will remain that way until the box has moved clear of the proximity sensor. Let's look at it if it is true. Now watch. Okay, you can see. You see the full lamp. It comes in until, okay, let's slow it down. Let's slow it down a bit. Let's slow it down a bit. So now watch the full lamp. It remains on until the box passes through the probe sensor. You see, it's good. That's beautiful. So if this run lamp will remain on until I press this stop from the control panel. Watch. Once I press this stop, the run lamp will go off. You see, everything is off, and I can restart again. Beautiful. Thank you very much. This is me, MMP. Nourishing you direct from the automation studio of Circuit Space Engineering Services. See you in exercise 2.